Okay, guys, let's go ahead and get started. So we're going to cover the electromagnetic spectrum. So up here it says 8.8c, explore how different wavelengths of the electromagnetic spectrum, such as light and radio waves, are used to gain information about distances and properties of components of the universe. So here we have the electromagnetic spectrum. You've seen this image before. It says, or let me go ahead and go a little bit over the information. The reason that I wrote right here, raging Martians invade Venus using X-ray guns, is because one of our colleagues from our school or from our district kind of like said that this is what she covers. Okay, and this is Miss Moore. She said that this is how she would kind of like have the students remember the order of the different waves or on the electromagnetic spectrum. So if you see raging is radio, M, Martians is for microwave, I is for, or invade for I is infrared, V for visible light, and U, ultraviolet, X-ray stays as X-ray, and guns goes for gamma rays. So then this goes from the longest wavelength to the shortest wavelength. You're going to notice that sometimes they're going to show the same electromagnetic spectrum, but instead of starting with the longest wavelengths, they're going to flip it and they're going to start with the shortest wavelengths. So then you would kind of like start backwards. But if you remember this acronym, whether they give us the names of the different the names of the different wavelengths, you will be able to kind of like figure out their names based on the raging Martians invade Venus using X-ray guns acronym right here. So it says right here, electromagnetic waves have different wavelengths. Let me get my pen. They have different wavelengths. Waves in the electromagnetic spectrum vary in size, and you can see how I said that we started with the radio waves. They're very wide. When we're talking about the wavelength, like how long does it take from here to here, from here to here, from here to here? And as you can see, as we move towards the gamma rays, the wavelengths become shorter and shorter, and the shorter it is, the more energy it can hold. So they have a higher frequency, which means higher energy. Over here, the longer they are, the less energy that they're going to be holding from one wavelength to the next. So then we say that their frequency is going to be much lower. Their energy is much lower. So it says scientists use the electromagnetic, this is an E, use the electromagnetic radiation given off by components in the universe. So they're talking about by galaxies, by stars and all of that, to measure distances in space and the compositions and what they're made out of, okay, of objects in the universe. So here's once again the electromagnetic spectrum. In this case, we have the radio waves, which are 10 to the third power, microwaves, 10 to the negative 2, infrared, 10 to the negative 5, visible light, 10 to the negative 6, ultraviolet, 10 to the negative 8, X-rays 10 to the negative 10, and gamma rays 10 to the negative 12. So they're not going to have you, they don't want you to memorize this, guys. The information is going to be given to you here. All that you need to remember is that when they're asking any type of question, always look, am I starting with the radio waves, with the lowest, with the longest wavelength up to the shortest wavelength? And if they flip them, of course, you're going to start with the shortest wavelength, and then it's going to go up to the longest wavelength. And if the wavelengths are flipped, then the frequency is going to be the same. So you don't need to worry about memorizing this. So here, when we look at the wavelength, long, shorter, shorter. And from here, the frequency, you see that goes from 10 to the 4th power to the 8th to the 12th to the 15th. So that means that their energy increases. So I had covered this section right here. And it's giving you radio waves 10 to the 4th power. We're talking about frequency. I'm sorry. I'm supposed to be looking. Now, right here, frequency, it's measured in hertz. And it's right there. So all of this information is there. You just have to pay close attention and look for it, okay? So then Right here I went, okay, based on the frequency for radio. So then I look at frequency, and for radio, I just kind of like, I can put my pen, frequency, radio here to the top. If I want to know the frequency of visible light, I put my pen right here, and the frequency is going to be between 10, 12, and 10 to the 15th power. If I want the microwave frequency, so that's going to be 10 to the, to the 8th power. And the wavelength is going to be 10 to the -2nd power. So all I need to do is kind of like look up and down. Right here, this information was just transferred from this to this. Okay, this one's a frequency. Remember, hertz. And the wavelength is in by short or long. Now, it says right here, radio telescopes look at planets, comets, giant clouds of gas, stars, and galaxies. By studying radio waves from these sources, astronomers can learn about their composition, the structure, and the motion. Radio astronomy has the advantage because sunlight, clouds, and rain do not affect observations from radio waves, okay? So keep that in mind. At the bottom of this page, and it's at the bottom of page 41, we have the information for gravity. I'm not going to cover it until the next video. So right now we're going to go and answer some questions that have to do with the electromagnetic spectrum. The next video will be about gravity, and we can come back to page 41 once we do that. I just don't want this video to become a very long video, okay? And I'm already kind of like giving you the answer to that. Oh no, you didn't get to see it. So then let's go ahead and go to the questions now for electromagnetic spectrum. Okay, so then right here we have a little bit more information about the electromagnetic spectrum. This is page 42. We just cannot see it at the bottom. It says use the diagram below to answer the questions that follow. Again, I kind of like label shorter wavelength, longer wavelength. Right here they started kind of like backwards, gamma rays, x-rays. But if you look over here, if they start backwards, that means that the shorter wavelengths are going to be over here. So we can kind of like start making our shorter wavelengths. And then as we move on to the next pieces of information, we make this a little bit wider and wider and wider and wider. And this information right here goes with this. This one goes with this. This one goes with this. Okay. So then gamma rays are going to be the one with the shortest wavelengths. So then right here, again, it says short. It says long. I put over here gamma, X-rays, ultraviolet, and I started from top to bottom. So if I were to start from the bottom to the top, raging Martians invade Venus, so that would go backwards. Now it says which type of wave has the longest wavelength, and we said it was going to be radio waves. That's not going to change. That's always going to be the one that has the longest wavelengths, and we see it over here. So there's infrared, but it continues, okay? It doesn't stop there. If you look, I put the letters right there. X-ray, UV, visible light, infrared, microwave, and radio waves. They just kind of like put this, which is ultraviolet, and then visible light, and then infrared, and then it continues. They kind of like just make those stick out. Then it says right here, which type, so we already said that radio waves. Which type of wave has longer wavelength than infrared? So here's infrared. So I want longer than this one, but shorter than microwave. So then I want longer than infrared. Okay, so it's gonna be kind of like coming this way, but shorter than radio waves. So longer than this one, but shorter than this one. So I'm gonna end up with microwave. This one here in the middle. Okay, shorter than this one. Okay, I mean longer than this one, but shorter than radio wave. So that's going to be microwave. So I already put it right there. Which wave is used to identify heat given off by distant objects in space? If you remember, in case we forget, if you remember, or if you have watched videos about ghost hunters, they actually use infrared to detect the heat from an area. So they say, okay, this is red. There's something that is emitting heat. So that's one way that you can remember that infrared is the one that detects objects that give off heat. And it says, what type of wave are used to support the theory that galaxies are expanding? That one, guys, it's part of the visible light. That's the energy. When we're talking about visible light, we're talking about what we used to talk about in elementary. Did we said the colors of the rainbow? Those are the ones that are included in the visible light, which is red. We used to say Roy G. Biv. So we used to say Roy G. Biv. So I'm going to go backwards here again because it would be from the less, the one with the less energy, which would be the red for Roy, for R, O for O, and Y for Y. I mean orange for O and yellow for Y. So that spells out Roy. And then as I keep on moving, G for green, and B for blue, I for indigo, which is between the blue and the violet. Okay, so blue and then violet. So then from that one, it is going to be visible light, and that's what we call the red shift, the red. Now, if we think about Roy G. Biv, if we go from a color red, that's the one with the least amount of heat. So then as we move to the left, as we move from Roy G. Biv, it goes from a lot of some energy, red energy, more energy as I go orange, yellow more energy, green more energy, blue more energy, and violet highest energy. So if you think about it, our star is a yellow star, so we think about it as having a lot of energy in comparison to the red orange stars. So now we go to the actual question. Okay, so the actual question, our first question that has to do with the electromagnetic spectrum. I just wanted to go over all of that other information again. So let me go ahead and push this up. Here we go. It says quasars are extremely distant celestial bodies. So these quasars are very far away. Investigators using a telescope, okay, a special telescope, determined that a certain quasar was emitting wavelengths with a frequency right here. This word you need to circle in or square in. Frequency of 1.41 times 10.9 hertz. We need to make sure that we look at that hertz, because remember, our electromagnetic spectrum is going to be based on the hertz or on the wavelength. Okay, so then hertz is energy, and then we have the wavelength, and then it says an electromagnetic spectrum is shown, and there it is. So let's look to the question itself. The investigators were most likely using a telescope that detects, okay, so right here, guys, when you look at your waves, we have the numbers for the waves right here. It's not asking for the wavelength, okay? It's actually asking for the hertz, okay? So if you look over here, these are the hertz, wavelength, and the hertz. So the wavelength goes with these numbers up on top. The hertz is going to go with these numbers right here. So this is not giving us the 141. There's nothing there. So I'm like, where does it go? Doesn't matter. Find your hertz. If they were to give us the wavelength, then we focus on the wavelength. This is the measurement for the hertz. So then I'm going to look for 10 with the power of 9 hertz. 10 with the power of 4 with the power of 8. Power of 9 right after 8. So guess what? I'm going to put my pencil right here, and I'm going to say, where am I closer to? The microwaves or the infrared? If this is 8 right here, then I'm going to assume that this is around 9, this is around 10, this is about 11, and this is 12. So then it goes from top to bottom. So the closest one that I could say, it would be somewhere around here, which includes my microwaves. So I'm going to select letter A. Visible light is way over here. Okay, that would be like 10 to the more than 12. X-rays is way over here, 10 to the 18th. And gamma rays is 10 to the 20th. And I'm looking at these little numbers, and I'm putting my pen and I'm reading from top to bottom. So then the correct answer is going to be microwaves. This is page 43, and we're looking at question 22 right here. It says the temperature of a star determines the wavelength. So, okay, I'm going to put temperature determines wavelength. A visible light that is produced. The visible part of the electromagnetic spectrum is shown. And if we pay attention right here, guys, it says the light spectrum. Visible light is right here. So then we have the infrared over here and the ultraviolet over here. But it's showing us this. Remember when I say Roy G Biv? So this is R O. They didn't put yellow right here, Roy, and then G, and then B I V. Okay, and all of this kind of like goes all the way to the blue light over here. Okay, so then this is in reality, I guess, B I M V. So then remember that as we're moving from Roy G Biv, red, orange, yellow, green, blue, indigo, and violet. That as we move to the right from saying Roy G Biv, if you look at those colors, the more that we move towards from the red being the least, the one with the least heat, but it's still very hot, but it's not as hot as the blue or the indigo and the violet. So let's look right here. This one, no, this one's not as hot. Then we have the orange one, no, the green, and it is getting a little hotter, hotter, hotter. But then when we get to the blue one, if we had indigo and violet, of course, we would go all the way to the violet and choose that one. But right here, it is going to be J, blue light. So now we're looking still at page 43, but we're looking at question number 20. And for this one, guys, it says the diagram of an electromagnetic spectrum is shown. So again, it starts from gamma ray, from the shortest wavelengths, and then it goes to the longest wavelengths. If you remember the previous one, we kind of like started with the longest wavelengths onto the shortest. So here we have from most energy to least, or I mean from closest, shortest wavelength to the longest, which means that also the higher the, and it even says higher the frequency, higher the energy. Longer wavelength, lower frequency, lower energy. So you have to really look at all of the information that they're giving us in order to answer the questions. I'm going to throw in the word science because I'm going to ask you to actually write that word on the section, at the beginning of the section that has to do with the electromagnetic spectrum. That's just for me to find out that you're really listening to this video, okay? So you'll get credit for that. If you do not, that's telling me you're not listening to the video, so you're not getting the full learning experience. So let's go back to the question. It says a diagram of the electromagnetic spectrum is shown. Once again, we go from the highest to the, from the shortest wavelength to the longest, which means from the higher frequency to the lower frequency, which is lower energy, from high energy to low energy. It says Earth's atmosphere blocks short wavelengths. So I guess all of these gets blocked by the atmosphere of the electromagnetic spectrum. Which telescopes must be placed in orbit around the Earth in order to observe the short wavelength? So then right here, so then we have here the short wavelengths. So the answer should be would be gamma rays. Okay, so we would need let me see, a telescope, okay, that is able to, a telescope in orbit that should be able to see short wavelengths because gamma rays have short wavelengths. Visible light, they're longer. Infrared, even longer. Radio waves, even longer. So then the correct answer is letter F. Thank you, guys. I'll see you. Make sure that you watch the video and listen to the information. Thank you.